When temperatures drop, most animals run, burrow, or migrate. The wood frog stays where it is and allows itself to be encased in solid ice. Inside that icy shell, the amphibian goes silent. Its breathing stops, its heart ceases to beat, and its blood freezes solid. There are no vital signs. Under a medical examination, this frog would be classified as clinically dead. But crossing this biological threshold is an evolutionary strategy for surviving the season. To understand why this is possible, we must look at the chemistry of living things. Animal bodies are comprised mostly of water. When water drops below freezing, its molecules rearrange. They expand and lock into rigid, jagged ice crystals. In a typical animal cell, these crystals act like microscopic needles. They physically pierce through the delicate cellular membrane. The force of that expanding ice tears the cell structure apart. Once the membrane is punctured, the damage is irreversible. This physical shredding of tissue is why extreme cold is usually lethal. But somehow, the wood frog survives this process without its cells falling apart. The defensive sequence begins the moment ice touches the frog's skin. That physical contact triggers an internal alarm. Immediately, the frog's liver enters a state of rapid activity. It begins synthesizing massive volumes of glucose and pumping the sugar directly into the bloodstream. The cardiovascular system distributes this heavy glucose load to every vital organ and individual cell before the blood itself turns to ice. The frozen state is an active chemical response, shifting the frog's internal environment to protect its organs while the exterior world freezes. In this context, the glucose functions as a biological antifreeze. The frog allows the extracellular space between its cells to freeze solid. Inside, high glucose concentrations lower the freezing point, preventing ice from piercing the membrane. Instead of crystallizing, the internal liquid becomes a viscous syrup, staying fluid at sub-zero temperatures. While the frog appears to be a lifeless block of ice, its cellular machinery is suspended in time, perfectly cushioned by the sugar. By sacrificing the space outside its cells to the ice, the wood frog keeps its vital organs intact. As spring arrives and temperatures rise, the external frost melts away. Inside the frog, the syrupy glucose mixture thins, and the blood returns to a liquid state. Then, without any external stimulation, the heart spontaneously begins to beat again. Within a short time, the frog resumes normal movement, hopping away as if the months of clinical death never occurred. The wood frog effectively manipulates the laws of physics to return from a state that would be fatal to almost any other creature. Medical researchers are now studying how this sugar deployment works at a molecular level. Currently, we struggle to freeze human organs for transplant because the ice crystals destroy the tissue. The wood frog has already solved this problem. Applying these biological insights could allow doctors to safely freeze, store, and eventually revive human organs. Evidence for the future of cryopreservation is currently sitting in the frozen leaf litter of our forests, inside the liver of a 3-inch frog.